at the top of page 58, please draw the following triangle. Now watch closely. What have I done differently than you're used to seeing? I put the right angle up top and I've made the hypotenuse the horizontal one. Does that matter? Of course not. Now we're going to name this triangle. We're going to name this triangle with 3 random letters that are not in alphabetical order. I'm doing this on purpose. We're going to name this triangle, okay, D, Z, and G. Everybody cool? Okay. What does that make this side? Little g. What does that make this side? Lil d. What does that make this side? Lil z. I'll take the cross off so it just looks like Lil z. Z was a bad one. It looks like 2, but that's fine. Everybody knows this, yeah? Right? Right now, I'm going to put a red theta, and I'm going to put a green theta. Why did I put my thetas where I put them? Why am I only allowed to call those 2 angles theta? They're unknown. Exactly. And can we do trig with the 90-degree angle? Yet. No, we can't. So that's why we're here. The only trig you know right now is you know tan of red theta is what? What is every tangent equal? Opposite over adjacent. Now, put in what you know. What is opposite red theta? D. What is adjacent to red theta? G. It can't be Z Sade. Why? Because Z is the hypotenuse. He already has a name. He doesn't get to have 2. Everybody good? Okay. What is the tan of green theta? It's still opposite over adjacent, but it is G over D. Is everybody cool? Now, no matter where we are in the triangle, we know that we can work with this side. That doesn't really show up as green very well, but whatever. We know we can work with this side, and we know we can work with this side, yes? You guys are smart people. What side haven't we talked about? The hypotenuse. We have not talked about the hypotenuse. Now, we're aware that opposite and adjacent will give us something important, but we're also aware that there's this third side to the triangle, and the third side is the hypotenuse. And indeed, there are 2 more ratios that work with that side. The first one is the sine ratio, which on your calculator is the sin button, which is why I'm writing it in red. Okay. Now remember, what angles can we do this with? The 90 or the other 2? What angles can we do trig with? The 90 or the other 2? The other 2. So remember, these are not the 90-degreer. And the sine ratio compares the opposite to the hypotenuse. Sine, opposite and hypotenuse. So let's come up here and tell me in this question, what is sine of red theta? You already know what's opposite to red theta because you've already done tan. So what is D over what? Z, because that's the hypotenuse. What is the sine of green theta? Which you're going to do in a second, but my computer's frozen.
G over Z.
G over Z. G over Z. Is everybody cool? So remember, that last page we did, we had to know both sides. That very last question, the ladder question, we had to do Pythagoras to find that side, didn't we? But now, I'm learning trig that uses the hypotenuse. Right? So let's go to the next one. This one is called the cosine ratio, which is the cos button. Again, I don't work with the 90. I only work with the other two. Now, you guys are smart people. We've done opposite over adjacent. We've done opposite over hypotenuse. What's the only one left? Opposite over adjacent. Opposite over hypotenuse. What's the only one left? Adjacent over hypotenuse. And this one causes a lot of trouble because you all remember adjacent as being beside the angle you're working on, yes? Except what is the cos of red theta? When you look at that drawing, there's two sides that are beside red theta. But, as we just talked about with Sade, one of those sides already has a name. Which one? The hypotenuse. So the hypotenuse can never be your adjacent or your opposite. Does everybody understand? Because the hypotenuse already has a special name. So what is the cos of red theta? G over Z. And what is the cos of green theta? D over Z. Now please notice something. The sine of one of the angles equals the cos of the other angle. So the sine of one angle equals the cosine of the other angle, which makes sense because they're all related because they're all in the same triangle. Is everybody cool? All right. Now that we have dealt with all three, you get to learn this fake word that isn't a real word. Okay? Every math teacher uses this. It's pronounced Sohcahtoa. We all say it. Every math tutor says it. Everywhere says this word, but it's not a real word. It's an acronym. And the acronym stands for sine, opposite, hypotenuse. Cos, adjacent, hypotenuse. Tan, opposite, and adjacent. I don't like to write it sideways. I usually write it this way. Sohcahtoa. But you don't even need to have it memorized because, of course, I give it to you in your data booklet right there. You don't even need to have it memorized. And I even show you how to label a triangle. So if you can't remember, it's in your data booklet. So let's do a couple of these things. But there's a bunch of white space here. There's a reason for that. Actually, I think I'm going to trust you guys. I believe you. We're going to leave that blank for a sec.
Oh, no.
Now, we're doing trig. Have we done some trig already? Yeah, we've done stuff with tan, yes? And since we're doing trig, and we know trig is part of math, and we know we have a method that works with tangent part of trig, will that method work now? Of course it will, because if it works once in math, how often does it work? Always. So what was that method? The first thing was always to choose what? If you don't remember, you can look back in your notes. What is the first step always? We have to choose what? We did this yesterday. It was a long time ago, I know. I'll refresh your memory by going back in your notes. What is the first thing we did on every single question? We identified theta, the angle with which we are interested. Is there a theta in number 7? There's not an angle in number 7 that I'm interested in?
Yeah.
What is it? Theta equals 12. Once I have established what theta is, that means this is my point. Theta is where I decide what? What are the two sides of the triangle I get to name? There's only 3 sides, opposite, adjacent, and hypotenuse. Which are the two that I get to name? Opposite and adjacent. The theta is where I decide the opposite and the adjacent. So if this is theta, here I am, ready to decide. There's my gray hair. There's my eyes and my smiley face. So now that I'm set up, I need to look. What do I have in this triangle? I have that. What is that spot on the triangle? Opposite. So opposite equals what value? X. What else do I have? I have that side. What is that? That is the hypotenuse. Even though it's beside theta, it's the one that has its own name. It's the hypotenuse. Hypotenuse is 25. Now, Sohcahtoa. Which one uses O and H? That's what I did when I was in grade 10 too. I said, oh, it sounds Japanese. Sohcahtoa! Right? Which is totally racist and horrible. And my math teacher got mad at me in grade 10. I won't get mad at you. But my math teacher got mad at me in grade 10. I had a thing with my math teacher in grade 10 because he was a super good-looking man, like you guys have for a math teacher. And my girlfriend in grade 10 had a mad crush on my math teacher. And every day I would leave math, she would say, I'd walk out, I'd meet her in the hall because she had English 2 doors down with Mrs. Fowler. I'd walk out, she'd walk out, we'd meet, and she would all be like, how's Mr. Stewart? She wouldn't say, how did math go? Right? I was her boyfriend. She didn't say, how was math? Because I was not very good at math. So she knew that I was, stressed about going to math class. Never asked once. 180 school days. Because we had math all year. How's Mr. Stewart? He's fine. It was frustrating for me. Now, anyway, let's move on. What do we use? Which one? Sohcahtoa. We have to use sine or cos. Which one uses the O? Sine. Sine theta is O over H. Well, fill it in. Sine of what? Sine of what? Sine of what? Sine of what? 12 equals O, what's O? X over H. What's H?
25.
25. Now, when it was tan, we did 25 times tan 12. What are we going to do this time? Sin 12. We're going to do the same work, but we're going to hit a different button. 25 sine 12. What math do I need right there? Some calculators make me have to push this button. Not all. That's got to be times. What is the answer? What is 25 times sine 12? 5.19. What's the next number? What's the next number? 7. So we would round that to 5.2. Does everybody understand? See how it's nothing new? We're doing the exact same thing, except now we get to use the hypotenuse, which means we can let Pythagoras go. Pythagoras is free. He has been let out of his triangular prison to go. Well, sometimes you still may, right? Just like sometimes you still actually need to unscrew a screw with a hand screwdriver. But 99 times out of 100, you can use something with power. But you still got to know how to do it with the regular one. Because eventually,
You won't have the tools on hand.
The Walking Dead is going to happen and there'll be no more power. It's not really, don't worry. That's fiction. It's not going to happen.
There are such things as
But what may happen is we may very well have to stop producing energy on our planet because we'll have used all the fossil fuels and won't have bothered figuring out something new to do because that's tomorrow's problem. All right, we're all good? Okay, now we have a method. Will that method work forever? Of course it will. What's the first thing I do with the second question? Find theta. What is it? 19. Theta equals 19. Once I have theta, there I am. Now I'm right there. Now I get to name the sides. What is this side that I have? It's 40, but what side is it? Is it, I can only name opposite and adjacent. Which one is 40? Adjacent. Why? Because it's not across, it's beside. So adjacent equals 40. What is this side? The hypotenuse. Why? Because we didn't measure it, Ryan, it's across from the 90-degreer, right? But you can see that it's the longest. So what uses A and H? Cosine. Cos theta is A over H. Fill it in. Cos of what? Cos of theta is A over H. So what's theta? 19. What's A? 40. What's H? X. When the letter is on the bottom, what math do I do? Division. 40 divided by cos 19. This is the hardest one if you have a backwards calculator. Once again, remember, when you hit 19 cos on your backwards calculator, the screen is going to change. Is that the answer? No, Elijah. When do you get an answer on your calculator? When you press enter or equals. Until then, you don't have an answer. What is it? 42.3? Does that make sense? 42.3 is longer than 40, and 19 isn't a very big angle, so it won't have spread very far apart, right? So that's a good answer. Sukman. Do you have a forwards calculator or a backwards calculator? Forwards. So you need to type this. Okay? Watch. You need to type, for this question, 40 divided by cos 19. You don't need brackets. Divided by cos 19. Now, some calculators put a bracket there automatically. Does yours? Yeah. Then you don't need to in a one-step equation like this, but get used to closing that bracket, because when we go later on, you're going to need to close it, and then push equals, and you should get 42.3. Yeah. If you don't get the answers that we are getting, what does that mean? Does it mean you're pushing the wrong buttons? Does it mean you're doing the work wrong? No, we've got all the work here. If you've done what we've done, but you are not getting 5.2 and 42.3, that means your calculator's in the wrong mode. What mode must it be in? D or DEG, somewhere on the screen. And let's do the last one. What do I have? Do I have a theta? I have an angle I'm interested in, but I don't have a value for it, so it gets an X. But that's the angle I'm interested in, so that's where I go to decide my O's and A's. What do I have?
You have the adjacent and the hypotenuse.
I have an A of what? Oh, the lines are disappearing. That's always a good sign. Let's just close this off. 13 for A, and what else do I have? Hypotenuse, which is what? Okay, so what uses A and H? It's coming back. Cos. So I have my A of 13, my H of 22. So I know cos theta is A over H. But there's a problem, because theta is now an unknown. My A is 13, my H is 22. What did I do with tan when I needed to find an angle?
You would take the 13 over 22 or the opposite over adjacent, yada, 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 and you'd put the tan negative 1.
Yeah, you had to do shift tan. So what do you think we do with cos? Shift cos. What would I do with sine? Shift sine. Doesn't change anything. So I shift cos. Now here's where you need your brackets. You got to do 13 divided by 22 in brackets and then hit equals. If you've got a backwards calculator, you got to reverse this. 13 divided by 2, shift cos. And what do you get for an answer? 53.78. So since it's an angle, we round it off to 54. Is everybody good? The only change is now you have 3 choices. You're not locked in to the legs. You can use the hypotenuse. Everybody cool? All right. It's a short day, and it worked out perfectly that this lesson was on a Thursday. Please try 59 and 60. Now, if I could call your attention to number 7 on page 60. It looks like crap on my. I bet it looks bad on yours. So this is what it needs to be. This you can read is 25.23. And I think it looks better in one of the other classes. I think it looks better. Yeah, 58.5. And this down here, the angle is 58.5 degrees. Now, what's weird about that question? We don't usually have angles at 58.5 because angles aren't measured in decimals, okay? But you've been given an angle of 58.5. So what is your theta going to be if you do this question? You're going to use 58.5, okay? In reality, if you're out in the real world, angles do get broken down. And in the real world, it makes a difference. So, but for you guys, we leave them as decimals sometimes. Everybody with me? In reality, this angle is 58 degrees, 30 minutes. Because we measure degrees in minutes and seconds like we do time. But don't worry about that. Just use the 0.5. Everybody cool? All right, now, next thing. And this is where you guys get, it's dangerous for me to say this, but I say it anyway. The answers are all right there, aren't they?
That's good.
Everybody with me? Okay. But what have you noticed about trig right now?
If you don't show your work, you're probably wrong.
Okay, what else? Does it follow a pretty set pattern? It does, doesn't it? Does it ever change? No. The numbers change, the way we turn the triangle changes, but the math doesn't change, right? So, if you're comfortable and you're willing to risk it, I don't need you to do every question here. I recognize you guys have lives. But that being said, that is not a license to do nothing. Do you understand what I am saying? You have to know how to do this stuff. If you feel you've got it, all the way down the page, you've been kicking ass and taking names all the way down here, try the last question and make sure. Same thing on the next page. You've gotten everything right, try number 10. Picking up what I'm putting down? Do as much as you feel you need. Because the answers are right there. I'm not going to mark it. You have the answers. You're all getting 100%. But that being said, when I give you a quiz, you need to be ready to do it. Everybody okay? Okay. Now, the more astute members of the class will notice there's a quiz coming up. These three things right here, if you look at the next 3 pages in your book, there's nothing new. They're little puzzle sheets. Okay? I want to do those puzzle sheets on Monday because there's nothing new and you don't even need your calculator for one of the 3 of them. And I want to do that quiz on Monday because quizzes aren't worth anything, so it doesn't matter. Okay? So on Monday, because we're back to an 80-minute block, we'll do these 3 puzzle sheets because they don't take long at all, and then we'll write our quiz. Everybody cool? If you're like me, and you're like, man, I love trig, I can't get enough of it, which none of you are, and I know you think I'm weird for loving trig, but I do love trig. If you want to go ahead and try those puzzle sheets, you can because you already know how to do trig. There's nothing new on. There's no new skill there. It's just this. But at the end of it, you get 1, 2, 3, like 5 dad jokes out of the deal. And it is Dad Joke Thursday.
We just skip that then?
Huh?
We just skip that then?
I would, if you want to do that, that's fine. But again, Michael, I would recommend you do the word problem ones. I don't mind if you skip all these triangle ones because you got it. But I would really recommend you try all the word problems. Okay? And I would also recommend, if you don't mind my saying, trying a couple of weird twisty triangles that aren't the way we're used to setting them up. That's what I would do if I were in your shoes. Okay? Everybody cool? Go.